But before we continue, I give you the simple games. Yeah, please answer if you know what is the correct word from this one. If you know, just answer. Turn on your microphone. What is it? The correct word. Can you answer it, Alexander? Alexander, huh? What is it? Who knows? What is the correct word? Can you read it? Yeah, Tikul Soyo Chan. What is the correct word? Tilquiseo Can. Nobody knows?
Anti-clockwise, Miss.
Okay, good. Good job. Anti-clockwise. Yeah, anti-clockwise. Very good. Anti-clockwise. What's your name?
Christine.
Kristen Angel. Okay, good job, Kristen Angel. Next. What is the next?
Clockwise.
Yeah, clockwise. It's easy, right? Clockwise. And then the last. Momsen. What is the correct one? Yeah, moments. Yeah. These terms, yeah, will related to our subtopic, the principle of moments. Yeah, we will learn about the moments. Yeah, we will discuss about the which one is clockwise, which one is the anti-clockwise. Okay, the unit 5.2 principle of moments. Yeah, in this section, yeah, at the end of this section, you should be able to state the principle of moments for a body in the equilibriums. And then last, you should be able to use the principle of moment to solve associated problems on daily life. Okay, before we continue discuss the principle of moment, yeah, let's recall the subtopic 5.1, the moments. What is the symbol for moments? You know, symbol for moments? Yeah, it is the symbol for moments, also known as the charge. And this is the formula for moments. Yeah, it's F times D. Torch is a moment. And then what is the unit of moments? The international standard unit of moment is Newton meter. And F, yeah, is a force. Has the standard unit Newton. And what is D? Yeah, D is perpendicular distance. Yeah. The symbol for perpendicular distance is m, meters. This is the moments. Yeah, because the moment is a vector. Remember, you have learned the vector, right? With Miss Rachel. The vector should have the magnitude and direction. And what are the direction of the moment? Yeah, it's the clockwise and anti-clockwise. This is the direction of the moment. It can be clockwise, it can be anti-clockwise. Yeah, why does a beam balance measure mass? Yeah, why does a beam balance measure mass? Yeah, this is the diagram that shows the clockwise and anti-clockwise force. This is the clockwise. Clockwise first, and this is the anti-clockwise. Clockwise. For example, this balance, yeah, we can use the standard mass, the mass standard, to measure the weight of an apple. Yeah, because the position of the beams, is horizontal. This is horizontal. Yeah, it shows the beams is balanced. It's horizontal. Now we check how does a beam balance measure mass. From this diagram, we calculate the anti-clockwise moment. What is the anti-clockwise moment? Remember the formula of moments. Torque is F times the perpendicular distance. What is F from anti-clockwise? This is anti-clockwise. Anti-clockwise. The force is mg. The force is mg, and then multiply by the perpendicular distance. The perpendicular distance of apple is d. To the pivot, from the apple to the pivot. Next, how about the clockwise moment? The clockwise moment, this is the clockwise moment. 3sg. 3sg multiplied by the perpendicular distance d. For the beam balance, the turning effects of the clockwise and anti-clockwise must be equals. And then make it equals. The anti-clockwise moment is equal with the clockwise moment. mg multiplied by d is equal by the 3sg times d. Therefore, because we can cancel d, we can cancel d, we can cancel g and g. That's why m is equal with 3s. Thus, the mass of apple m can be measured by the standard masses 3s. The next, what is the principle of moment? This is the definition of the principle of moment. When a body in equilibrium, the sum or the total of the clockwise moment is equal with the total of anti-clockwise moment from the pivot. This is the formula. The symbol is sum, sigma. Sum, clockwise, this clockwise moment is equal with the sum anti-clockwise moment. Because the torque is F times D, so the sum of F times D clockwise is equal with the sum of the F times D anti-clockwise. And this is the experiments to verify the principle of moments. We use the meter rule, various weight, W1, W2, weight 1, weight 2, cotton loops, knife, and retort stand. From the experiments, based on the variation of the weight, when we use the weight 1 is 0.5 Newton, and then weight 2 is 0.4 Newtons, for examples, we can find the suitable distance that makes the apparatus balance. The D1 is 32, D2 is 40. When we find the anti-clockwise moment and clockwise moments, we find it equals 16, 16, and also with the other experiments. 18 is equals also 18 for the clockwise. When the anti-clockwise 16, clockwise 16. 18 and 18. So we can conclude based on this experiment that the principle of moment show that anti-clockwise moment is equal to the clockwise moment about the pivot. So we also can use the formula, yeah, weight 1 times D1 is equal with the weight 2 times D2. Weight 1 D1 is equal weight 2 D2. That shows the principle of moment. Okay, next. This is the questions number 1. Yeah, a uniform rod is balanced using a string at B and a counterweight of 20 Newton at C. Balance, yeah, at B. So what is B? The first step, yeah, we should identify, yeah, which one is the pivot. Because balance at B, so we can conclude that B is the pivot. And then weight 20 Newton. 20 Newtons can be weight. Yeah, it can be W1 or F1 is 20 Newton. Find the moment of the 25 Newton weight about the pivot. This is the F2. 25 Newton. Find the moment. But this is the question A. How to answer the A? What is the formula that we can use to find the moment? What is the formula to find the moment? Yeah, torque equals F times T. What is F?
25.
25 newtons. What is D?
60.
0.6.
0.6.
Okay, 0.6. Good job. 0.6. What is the unit for perpendicular distance?
Meter.
Yes, meter. How to find 0.6 meter? Yeah, this is the D1. D1. Because the D1 from 10 centimeters into 70 centimeters. That's why 70 centimeters minus 10 centimeters. Yeah, it's 60 centimeters. But the centimeters is not the standard unit for perpendicular distance. The standard unit is meter. Yeah, it's why the D1 is 0.6 meter. Good. What is the total of moment? 25 times 0.6?
50 Newton meter.
Yes, 15 Newton meter. Okay, correct. 15 Newton meter. Correct, yeah, the point A. Next, the point B. Find the D2. What is the formula that we can use to find the D2? What's the formula?
15 over 20
15 over
over
20.
the force. Yeah.
Yeah, let's rewrite from the formula, yeah. The sum of the torques clockwise is equals with the sum of the torques anti-clockwise. The torque is F1 clockwise. Clockwise is D2, right? The D2, F2, D2 is equal with the sum of the F1, D1. F2, D2. This F2 is F1. F1. F2, D2 is 20 times D2 is equal with F1 25 Newton multiplied by the 0.6 meter. Because the D1 is 0.6 meter times 25. So what is the D2? 25 Newton times 0.6 meter divided by 20. 20 Newton. We can cancel Newton. Can cancel Newton. Can cancel Newton. Cancel Newton. 25 divided by 20. 4 is 5. 2 is 0.3. So it should be equal 5 times 0.3 is 1.5 divided by 2. And then the unit is meter. What is the answer?
0.75.
Yeah, 0.75. Okay, correct. Meters. If you want to change the unit into centimeters, what is the answer in centimeters?
75 centimeters.
Yeah, 75 centimeters. Yeah, this is the 75. 75 centimeters, the dito. Okay. Next, what is the condition for the equilibrium? Yeah, for an object to be in equilibrium, yeah, all force acting on are balanced. The resultant force is 0 and also the resultant of moment 0. Resultant force 0 and the resultant moment also 0. Yeah, that's the conditions for equilibrium based on the principle of moment. Next question. If you could show a hand winch, the hand winch is used to move a load of 5,000 Newton. What is the minimum force required to turn the drum? What is the first step? Yeah, the first step, yeah, we have to write the diagram that show the principle of moment. Let's draw the diagrams. This is, and then let's find the pivot. This is the pivot. And then identify which one is the clockwise, which one is the anti-clockwise. What number shows the clockwise moment? Number 1 or number 2, the clockwise? Yeah, number 1 is clockwise. So the number 2 is anti-clockwise. And then draw it into the diagrams. Yeah, so the distance from the effort F until the pivot for the anti-clockwise. What is the distance? 4 meters. How about the distance from the clockwise moment? Is 0.2 meters. How about the force in the clockwise moment? Is 5,000 Newton. And then next, let's find what is the minimum effort. Is the effort for the anti-clockwise. So total or sum of the force times perpendicular distance per clockwise is equals with the sum force time perpendicular distance for anti-clockwise. Anti-clockwise. What is the force for clockwise? Force for the clockwise? Yeah, this is the clockwise. Force is 5,000 Newton. 5,000 Newton multiplied by the perpendicular distance. What is the perpendicular distance?
0.2 meter.
0.2 meters. What is the force for anti-clockwise? Yeah, this is the we need to know the F for anti-clockwise. And the perpendicular distance for anti-clockwise?
4 meter.
Yeah, 4 meter. So F equals 5,000 Newton multiplied by 0.2 meter divided by 4. We can cancel it too. It should be 0.1. 0.1 multiplied by 5,000 is 500 divided by 2 is equals
250.
250. What is the unit? You can cancel unit meter. So the unit is
Newton.
Newton. Oke. Apa nih Miss? SK. Wait for a while ya. Udah. Oke. Tangan. Terus untuk Kristen. Oh. Oh. Fotokopi. Oke, makasih Kristen. Oke. Do you understand?
Yes.
What did I explain? Okay. This is about the principle of moments. And then levers are the example of machine that make use for the principle of the moments on daily life. When apply a force at one end of the lever, load may be lift at another end. For example, we find the pivot from the scissors. This is the pivot. There are two anti-clockwise there. This is anti-clockwise. Also anti-clockwise. This is the clockwise moment. It's also clockwise moment. This is the pivot, the position of pivot. This is anti-clockwise moment. This is clockwise moment. Next, the number 3 is the pivot. This is the clockwise and anti-clockwise moment. The pivot, clockwise and anti-clockwise moments. Based on the principle of moments, the total of anti-clockwise moment must be equal with the total anti-clockwise moment. Let's go back to our starting questions. Okay. What is the answer? It will be easy for you.
Is it 1 meter?
Yeah, it's 1 meter. It's easy, right? 1 meter. How to calculate it? Multiply it and divide it by the 1000. Right? 500 multiplied by 2 is 1000. 1000 Newton meter divided by the 1000 Newton. Unit meter, 1 meter. It's easy. And then next is about test yourself 5.2. State the principle of moment. Who knows the principle of moment? And discuss how this principle of moment may be used to balance a seesaw by 2 persons. How to make it balance? Who can make the conclusions? Who can state the principle of moment? Who can state the principle of moment? May I call Gundila Visela? What is the principle of moment, Gundila Visela? Okay, let's repeat again The principle of moment states that the total moment of the clockwise is equal with the total of moment anti-clockwise. This is the principle of moments. And then how this principle of moment used to balance a seesaw. We can conclude the higher persons, have to sit near to the pivot. Only 1 meter, right? The distance. The higher persons have to sit near to the pivot. How about the lighter persons? How about the lighter persons?
Need to sit in the
Mm.
further back from the pivot.
Yeah, from the pivot. Okay, this is the conclusion from our lesson today. Yeah, based on the daily life. This one. Yeah, when a body in equilibrium, the sum of the clockwise moments is equal to the sum of the anti-clockwise moment. Yeah, this is the principle of moment. Principle of moment. And then how? Yeah, the heavier person has to sit nearer to the pivot. Yeah, only 1 meter. Yeah, the heavier persons. But the lighter persons have to sit farther away from the pivot to make it. Yeah, this is how balance.